Okay, in this self-check, I'm asking you to implement some methods, times, divide, minus, and also some comparison operators, greater than and less than. Now the reason that we want to implement these as operators is because we want to make our fraction class as user-friendly as we can. Right? If you're working with fractions, it would be nice to just be able to say fraction 1 plus fraction 2, or fraction 1 times fraction 2, or compare them using the normal less than or equal to symbols that we find on the keyboard. So the first thing to really think about with this is that everything in Python is an object, and we've been saying that since day one. And all these operators are plus, minus, times, etc. These are all syntactic sugar for what we call magic methods or underscore methods. Go by a lot of different names. But the point is that because everything in Python is an object, what really implements these operations is always methods. And it's just syntactic sugar for us to use the plus sign rather than have a dot method called on an object. So just to show you that that is in fact actually the case, let's look at adding 2 plus 2. We can do it just like this. And notice that we get 4, just like we do when we type 2 plus 2. So these two operations are 100% equivalent. What happens when you type 2 plus 2 is that Python translates this 2 plus 2 statement here into a method call where it takes the 2 on the left hand side of the plus sign and calls its underscore add method and passes it the thing on the right hand side of the plus sign as a parameter. Alright, now there's tons of these things, and so here's a list of them that you can find. This is just from the standard Python documentation, and you can see that we've got all these functions or methods over here that can be called that correspond to the normal sort of syntax. Now in this table you'll notice that the underscore is omitted on all of these, I think just to make it a little bit easier to read. Okay, so our goal here is to just implement some of these other methods. So let's start out and let's take a look at the method for subtraction. Since we have addition already here, subtraction is going to look extremely familiar. In fact, so familiar that I'm just going to go ahead and copy and paste this right in. So we'll change the name to be sub. Alright, so now to get the new numerator and the new denominator, we are going to, instead of doing addition, we are going to subtract. So just like we did before, we're going to cross multiply our numerator times other fractions dot denominator, and we're going to subtract our denominator times the other fraction's numerator. So we're just doing that cross multiplication to make sure that the fraction is in common terms on the bottom. Okay, so we do the subtraction. The new denominator is our denominator times the other fraction denominator, and now we'll look for use our helper function to find the greatest common denominator. So we can use the greatest common denominator here to reduce our fraction to common terms. Okay, so we've got a little test program going on down here, and so let's take our two fractions there and let's add something here to the end that should be relatively easy to do. We don't have our less than implemented yet, but alright, let's make a couple of fractions. So we've got 2/6 which is the same as 1/3, and so let's print out f minus j. And when we run this, we see that we get, for subtraction, 0/1, which of course isn't exactly perfect, but 0/1 is in fact 0, which is what we should get if we subtract 1/3 and 2/6. Again, 2/6 is the same as 1/3. All right, so now let's look at multiplication and division. Again, it might be helpful here. Yeah, we'll start from So again, it's important to remember when we're defining these functions. Self is referring to the current fraction, and other is going to refer to some other fraction. Okay, so for us to come up with a new numerator and denominator here, the new numerator, when we multiply, is simply going to be self dot numerator times other dot numerator. And the new denominator is going to be self dot denominator times other dot denominator. Then once again, we will find our greatest common divisor of the new numerator and the new denominator, and then we'll return a brand new fraction that we create by doing our division. Right, so multiplication is pretty easy. We don't have to worry about getting things into common terms or anything like that. We just have to go ahead and do it. Now, division is a little bit more tricky. We could look at just doing div. There are, in fact, a couple of different division operators that we need to think about, especially in Python 3, where we have the double slash for integer division and the single slash here for division that's going to always return a floating point number. So here are true div and our floor div. So true div does true division, floor div does the integer division. So let's go with true div here. And if we remember, division is just like multiplication, except for we invert one of the other fractions. So our new numerator is going to be equal to self.numerator times other dot denominator. And the new denominator is going to be self dot denominator times other dot numerator. Right? This is just thinking about multiplying or dividing 1/5 divided by 1/2 is really the same thing as 1/5 times 2/1. So we're just doing the cross multiplying over here. And by now we should be doing a very familiar operation of coming up with the GCD of the new numerator and the new denominator, and then we're returning the fraction of the reduced fraction by dividing by the greatest common divisor. Okay, so there we've got all of our basic operations: add, subtract, multiply, true division. I think you could go in now and add integer division fairly easily as well. Okay, so now let's look at this list of comparison operators. So we've looked at equality to test if two things are equal, but what about less than and greater than? And so there, all we need to do is implement the LT and GT operators. So that's going to look quite similar. So in fact, so similar that I'm just going to simply copy and paste these. So we'll do LT for less than, and when we do our cross multiplication here, self.numerator times other.denominator, other numerator times self.denominator. Now, if the first numerator is less than the second num, first num less than second num, then we will know that self is less than other. Similar down here, we will simply return first num greater than second num. Alright, so now we can go down and do a couple more tests here. Print g greater than f, print g less than f. Let's also print f times j, so that'll be 1/3 times 1/3, so that should give us 1/6. So print multiplication, and then let's also try division here, and let's print f divided by j, and that should give us 1. Alright, so if we run all of this, here we've got 1 with our division, multiplication 1/3 times 1/3 gives us 1/9, subtraction gives us 0. Is g greater than f, so g is 1/5 and f is 1/3, so that's false. Is it less than? Yes, it's true. So it looks like all of our operators are working just fine.